Today's lecture is on a new technique of integration. Up until this point, we've really only been able to do very basic things, right? So this is going to allow us to do a little bit more complicated integrals. And essentially, the integration using substitution method, it undoes the chain rule. Okay, so let's just use the chain rule a couple times. So what if f of x is equal to the sine of x cubed? So that would give me f prime of x is equal to cosine of x cubed times 3x squared. Okay, so what that means for us is that the integral of cosine of x cubed times 3x squared dx is equal to the sine of x cubed plus c. Okay, so what u substitution does is it helps us sort of, if you look here, like this whole piece right here, this derivative of the inside here is complicating, right? It doesn't show up back here at all. So what u substitution is it kind of pulls the derivative out of the way so that we can sort of see what we're actually working with, okay? So in our particular, this case, right? So u is the thing whose derivative is essentially complicating the matter. And so our u in this particular case, let me put my parentheses around here. So like to go backward using u substitution, my u here would be x cubed, okay? So now this dx says I'm going to do the integral with respect to x. So we need a way to say, okay, well, if we're going to switch from x to u, then we need it to say du instead. So that means what we're going to do then is, like, if I do the derivative of u with respect to x, that looks like du dx, like that's the Leibniz notation, and then the derivative of x cubed is 3x squared. So what I'm going to do, I know that this kind of looks like it, but it's not really, but we're going to treat it like it's like this du dx is a fraction. It's not really. These are differentials, and we're just going to, but for this technique, we're just going to multiply across the dx like it's like 1 over 3. Now it's really not, but we're going to treat it like that anyway. So that gives me du equals 3x squared dx. Okay. So if I wanted to rewrite this integral with this information, then that would look like, okay, so I have the integral of, so I want to write it completely in terms of u. So that would mean I would have the cosine of u, because x cubed was that, right? So cosine of u, and then 4, because I need to swap out my dx, right? So 3x squared dx is actually du. So this whole piece right here, so this is u, and essentially this here is du. So I'm in place of the 3x squared dx, I'm just going to replace it with the du. And so now I just have this integral, right? That's easy peasy. I know how to do cosine. The antiderivative of cosine is the sine of u plus c. And then we come back and we write it. Oh, wait, it was x. So I end up getting the sine of x cubed plus c. Okay, so it's a way to sort of uncomplicate it a little bit so that we can see, oh, it's really just cosine. And let me get rid of this derivative and I end up back at this. Okay, so let's just try to do some of these. Okay, so I have some steps written out here. Okay, so when we're doing the u substitution and we're doing indefinite integrals, it's a little bit different when we do definite integrals. We're going to look carefully and select the u, okay? So we want to be sure that u prime, the derivative of u, at least the variable part, is also part of the integrand, meaning under the integral. So in our case, like our du matched exactly, but what I mean by at least the variable part is I could have still used u substitution if this original integral, now I know I took it from here, but if I hadn't taken it from there and I just had x squared here, I could still do that because I can have like a method to get rid of, like, if it's just a constant. But there's no way that if I don't have this x squared here that I can do this, right? So that's what I mean, okay? So once we figure out the u and then we do the u prime, Then we do the substitution. We rewrite the integral in terms of u du, okay? Then we go ahead and do it. And if it's not possible, then maybe we choose our u wrong, so maybe we should try again. And then once we do the antiderivative, we just put it back in terms of x. Okay, so that's what we did in that first step. So let's just do some of these here, okay? Okay, so I have sine of x over cosine to the fourth. So in this particular case, right, I want to think the u substitution undoes the chain rule. Okay, so the chain rule, right, means that it's always inside of something else. That's kind of how the way to look at your u. So this is a little bit deceiving, but I could also write it like the sine of x, and then I have the cosine of x to the fourth. So if you think of u substitution as undoing the chain rule, like the u is almost always something that's inside of something else. So in this case, that would be cosine, okay? So our u is just plain cosine of x. Now, I don't want to use cosine to the fourth because cosine to the fourth is going to give me 4 cosine cubed as my first part, and I don't have 4 cosines cubed up here. So I can't use the cosine to the fourth. I'm just going to use the thing that it's inside. So this, I'm going to call this u as cosine. So now we do the derivative, which is really du dx, but I'm going to write du on this side. So the derivative of cosine is negative sine of x dx. So I just flopped over the dx in without writing it. I'm just going to write it like this. Okay, so now let's see. We do have this sine of x, right? It's sitting right here. And we don't have the negative sign, but that's okay. So there's different ways of writing this. Like there's different ways to think about it. I like to think of like, okay, what do I have out of this? And what do I still need to put in? Okay. So if I write this, I'm going to have, I know that I have u to the fourth down here. Okay, so let's figure out what do we need to put in du. Okay, so we have sine of x dx, so we have this part right here. So I need to get rid of this minus. So actually, because I want to make it an equal swap, so I'm going to divide both sides by -1 and get negative du is equal to sine of x dx. So now I have an equivalent swap. So I have u to the fourth because that's down here, that's just my cosine. And then for sine of x dx, or over here, right, I'm going to replace that with negative du. So basically I'm going to put a -1 here and a du. So now if I rewrite this, because now I have a power in the denominator, and I know in order to use my power, I have to rewrite it as the integral of, I'm just going to put the minus sign outside, u to the -4 du. So now I'm going to add 1, divide by the new power. So this is going to give me negative u to the -3 divided by -3. So this just becomes 1/3 because these become positive. And then the u to the -3 can be down here like this, plus c. Now we didn't, of course, start out with u, so we have to replace that. So it's 1/3 times cosine cubed of x plus c. So, all right, let's do another example. All right, so again, remember, my u substitution always is undoing the chain rule. So my u is almost always something that's inside of something else. And I always want to see at least the x part hanging out here, right? So I know that the derivative of the inside here is going to be 2x. I at least have the x, so I should be able to use it. So if this is going to be my u, so u is x squared plus 9. That makes my du 2x dx. Now, in order to make my swap, right, so far I have u to the 5th, but I need to swap out my x and my dx. So I have 2x dx, so if I divide both sides by 2, then I get 1/2 du is equal to x dx. So now I have this, I can make the swap, so instead of x dx, I've already written this part, I'm going to swap it in for a half du. So 1/2 du. So anytime I have a constant times the whole thing, I'm just going to shove this 1/2 outside because it's bothering me. And now it's nice and neat. And so now I can just use my power rule, which says I have a half u to the 6th over 6, which is going to give me a plus a c, u to the 6th over 12 plus c, and my u was this to begin with. So I end up with x squared plus 9 to the 6th over 12 plus c. Okay, so my u is always inside of something else, and then my du kind of takes away this other complicating stuff. Okay, secant squared of 8 theta minus 4 d theta. So this time instead of x, we're going to work in terms of theta. Now I know, and I hope you do too, that the antiderivative of secant squared is tangent. So it's not the secant squared that we have to contend with, it's this part right here, right? Now, I don't have anything else here, but the derivative of the inside of this would just be 8. So in this time, I really don't need my extra theta or something else hanging on the outside because I can deal with a constant. So I'm going to use this time, my u is 8 theta minus 4. So my du will be 8. And then since I'm in theta, that'll be d theta this time. So this time, all I have is d theta to swap out, right? Because this part will just be secant squared of u. And now to get rid of my theta, my d theta, I'm just going to solve for d theta because it's just a constant here. So I'm going to divide both sides by 8. So this is 1/8 du equals d theta. And so I'm going to put in my 8th du, swapping it out for this d theta. And I'm just going to stick, the constant can go right on the outside. So I'm going to put the constant out here and put my du here. It's all multiplication, so it doesn't have to be together. It can be wherever I want it to be. And that's how I kind of want it right there. Okay, so now I know that the antiderivative of secant squared is tangent. So I have 1/8 tangent of u plus c. And then I just put my u back in. So I have 1/8 tangent of 8 theta minus 4 plus c. All right, so another one. So I have 3 over 2x plus 1. Sometimes books will also write it like this, 3dx over 2x plus 1. It's just a different way to write it. I always, whenever I do these, whenever I was a student, I'd always stick the dx down. It bothers me up there. But so we'll just work with this one here. Now this 3 on top is just a multiplier. It would be like 3 times 1 over this. So I'm just going to take this whole 3 out here and stick it on the outside. So I have 3 times the integral of 2x plus 1, 1 over it. Okay, so 3 times this, we'll put it back up here. So, so I have this down here. Now I don't know how to do 1 over this, but I do know how to do 1 over x, right? So that would be the natural log. So this is going to be my u. Now I notice, again, this is a constant, right? The derivative of the 2 would be a constant. So I can deal with that. And I never just want to take one part. Like I don't want to just use u is 2x because then that when I come back, right, if I tried that, if I used u equals 2x, then my du would be 2 dx. And then I would have, when I go to replace it, I'm going to have some extra multipliers out here, but I would still have 1 over u plus 1, which doesn't make it any better than this one. So I want to take everything with it. Okay, so we don't want to use that. So we're going to use our u is the full 2x plus 1. Yeah, whenever there's a constant down there, take it with you because the derivative of it is 0. So our du will be 2 dx because we're just doing the derivative here. And let me put an equal sign in there. So let me rewrite here. So I have 1 over u, and then I have this 3 out here. Now I need to swap out, I forgot my dx here when I wrote it. So I need to swap out, I'm just going to leave the 3 outside, so we just won't even worry about that so much. So I need to swap out dx, and I don't have a 2. I have a 3, but I don't really want to mess with the 3 because it's not the real. So I'm just going to divide both sides by 2 and get a half du equals dx. And now I can put the half on the outside just like I did before. So when I multiply 3 by a half, I get 3 over 2. And I'm going to put the du in here. So I put in the half du. I just multiplied the half out here and put the du here. Again, it's all multiplication, so I'm allowed to write it in any order I want. So I write it in the order I want it to be. So now I remember that 1 over u, right, if I write that as u to the minus 1, that's the one time my power rule fails me. And I know that actually what I need to do here is it'll be 3 halves times the natural log of the absolute value of u plus c. So then now I just have to go back, plug my u back in, and I'm good. So 3 halves natural log of 2x plus 1 plus c. All right, hopefully you're kind of seeing, you really, it seems complicated, but you just kind of like, you have to do a few of them and then sort of stuff kind of clicks. Okay, so I have the integral of tangent dx. So if you remember when we first started doing antiderivatives, I was like, oh, we don't have the antiderivative of tangent, but now we can figure it out. So instead of tangent, right, just like when we did the derivative of tangent, we switched to sine and cosine. So we're going to use sine over cosine, sine of x over cosine of x dx. Okay, now you might think, well, I could use u as sine, or I could use u as cosine. And while that seems like likely, actually when you use the derivative, if I tried to use u equals sine, right, then my du would in fact be cosine. But that's not actually what I have here. I actually have 1 over cosine, right, because it's in the denominator. So be a little bit cautious about that. I can yank stuff out of the numerator all I want, but if it's in the denominator, I have to be a little bit more careful. So let me just say that for the record, whenever I have a fraction sort of thing, I would say 90% of the time u comes from the denominator. So instead we're going to use u equals cosine of x. Now our du will be negative sine of x dx. So replacing this, right? So I have sine of x dx. So this is what I have in there. So I'm going to swap out, divide by negative 1. Negative du is equal to sine of x dx. So I'm just going to swap out my dx for negative du. So I'm just going to put the minus sign outside because I just like to throw the constants out there. And then when I rewrite this, right, the sign is gone because that is part of the negative u du, or negative du here. And all I'm left with is 1 over u. So just like before, 1 over u, antiderivative is the natural log of u. So this is a negative natural log of absolute value of u, which is plus c, which is also equal to negative natural log of the u, which was cosine of x, plus c. Now this can be written in multiple different ways using natural log. In some books, they will actually, instead of writing it as negative natural log of cosine, because our log rules say, oh, this thing in front, we can put it up here as a power. So sometimes they write it as the natural log of cosine of x to the negative 1 power, right? Plus c, which 1 over cosine is really secant. So they'll say the natural log of the absolute value of secant of x plus c, right? But the negative natural log of cosine is fine. I'm just saying, if you see this looking different ways, it's because of these, when you use logs, a lot of times you can write them in different ways. All right, so let's do one more, a little bit more complicated. All right, so again, we always want to think, ooh, I've got that weird thing in the denominator, right? But my u always is, we're undoing the chain rule. So our u is the thing that's probably inside of something else. And this t to the 1/3 is definitely inside of sine. And conveniently, if I think, well, what would the derivative of t to the 1/3 be? Well, it would be 1/3 t to the negative 2/3, right? And like I said with the previous one, right, I don't really just have, in this one I had cosine, right? But I don't really have just plain cosine. It's really, this would be like sine times 1 over cosine. So this is the same thing. Another way to think of this would be that this is the sine of t to the 1/3 times t to the negative 2/3, right? Because it's down in the denominator, and to pull it up, it would look like this, dt. So now if I use u equals t to the 1/3, then my du will be 2/3 t to the negative 2/3 dt. Actually, not one, it's be 1/3, sorry. I got a little crazy with my 2/3. Multiply down my power in front, so that's 1/3 t to the negative 2/3 when I subtract 1, which is 3/3, right? Okay, so subbing in now, I know that this is u. Actually, this is the sine of u, sorry. This is my u. And I know that this is part of my du, right? That's my part of it. So what I have here is just t to the negative 2/3 dt. So this 1/3 I need to get rid of. So I'm going to multiply both sides by 3 because that would take it away. So 3 du would be equal to, then it's just left with 1, so I won't write it, t to the negative 2/3 dx. All right, so I know that this part here is my sine of u. And then for this, I'm going to swap in 3 du, putting the constant outside and the du next to it. Okay, so now my antiderivative of sine would be negative, and the 3 will be here, 3 cosine of u plus c. So this is just negative 3 cosine of t to the 1/3 plus c, just replacing my u back again.